Okay, all right, so here we're going to talk about coterminal angles. And reference angles. All right, let me just give some sort of a background here of an idea that if you have a circle, and suppose we're identifying this all in radians here. So the way I'm working on this is I start here at the x-axis, and we're looking at angles then that are in a standard position. So one side of the angle is on the x-axis, and we rotate the other side counterclockwise. So you start with your angle here and you get up to 90 degrees, and you keep going and you get 180 degrees, 270 degrees, and you get around to 360 degrees. All right, so I mean, what am I talking about? I'm looking at the angle here. Say that's 45 degrees, 90 degrees, 135 degrees. This flat angle is 180 degrees. And then, see, it looks funny to write it like this, but if we go around this way, this is 270 degrees, etc., and we get 360 degrees. Okay, so this picture here is something different than I studied when I was looking at geometry in high school. We would say this angle is 90 degrees, but it depends on which side you're looking at. This is 90 degrees when it's drawn this way, but when we draw it in the circle, then we get this idea that we can have angles more than 180 degrees. As you keep going 360, okay, let's just look at this 45 degrees. So 45 degrees is the angle I'm showing right here. It's half of 90. Okay, if I go all the way around 360, then I could look at this as 360 and just keep going. 360 plus 45, which turns out to be, I think I do in my head, is 405 degrees. So I have 45, I go around once more and I get 405 degrees. Okay, so the angles 45 degrees and 405 degrees are said to be coterminal. All right, and so coterminal angles are two angles in standard position that have the same terminal side. Okay, so let me do an example here. Where I'm going to list a bunch of coterminal angles. I'm going to put 45 degrees here. Now if I go, I'll draw the same picture again. So here I start, I go 45 degrees. If I keep going around the circle, once around the circle is 40, okay, so here's 45 degrees. If I go once around the circle, I get that I'm adding 360 degrees. Once around the circle is 360 degrees. Then if I keep going, I'm going to get 45 degrees plus 2 times 360 degrees. And then you can get 45 degrees plus 3 times 360 degrees. You can just keep adding each time. I can go the opposite way, which is opposite rotating, which would be clockwise. And so we have 45 degrees minus 360 degrees. 45 degrees minus 2 times 360 degrees, etc. So what do I see? All these coterminal angles are in the form of 45 degrees plus a integer. An integer, remember, is a whole number with a plus or minus in front, times 360. So we could have, here we have 45 plus 3 times 360. Now, if I take the difference of any of these two, say I take 45 plus 3 times 360 minus this one over here, 45 minus 2 times 360, the 45 would cancel out and give 0, and we'd get 3 minus negative 2, and we'd get 5 times 360. So what I'm getting at is that the difference between any of these two angles is going to be a multiple of 360. The difference between coterminal angles is a multiple of 360 degrees. Because you can think of the 360 degrees just means that we're going around the circle counterclockwise how many times, or clockwise how many times, k times. All right, so this can be used as a test to determine whether two angles are coterminal. What we can do is we can take the difference and see if it's a multiple of 360. All right, so we're going to look at this example where we show that 30 degrees and 750 degrees are coterminal angles. And so the solution is I take 750 degrees and I subtract 30 degrees and I get 720 degrees. We see that 720 degrees is equal to 2 times 360 degrees. So therefore 30 degrees and 720 degrees are coterminal. Okay, so to me, that's not really the most difficult. By the way, this could all be done in radians also. The difference between coterminal angles in radians is a multiple of 2 pi. So you could have degrees or you can have radians. Now, the next thing that we could do is we can say if we're presented with an angle, we can try to find a coterminal angle that is between 0 and 360 degrees. So find an angle theta such that theta lies between 0 and 360 degrees that is coterminal to alpha equals 750 degrees. Okay, so let's look at how we could do that. So first of all, you can sort of do it in your head and see what's going on. You can write off, you can see that 750 degrees is, well, what? It's 360 plus 360, which makes 720, plus another 30 degrees. Okay, because this was sort of a small number, and I was the one who made the problem, I could see that. But this is our coterminal angle. Because each of these additions of 360 represent going around the circle one more time. And so you can note that 750 degrees minus 30 degrees equals 2 times 360 degrees. So that's, an explanation why they are coterminal. Now, in a more practical way, what you can do is you can take your calculator and you keep subtracting 360 until you get an angle between 0 and 360 degrees. So you use a calculator and subtract 360 degrees until we get an angle between 0 and 360 degrees. So that would be, take 750 and subtract 360 and see what you get. Subtract 360 and see what you get. So you could do that. That's very reliant on a calculator. So if you're, I don't really always like having a calculator around at all. So, but here's another way we can do this. We take 750 and divide by 360. Well, this of course is long division, which is also not really the top thing that people like to do at all. So we see that this statement gives that 750 is equal to 360 degrees times 2 plus 30 degrees. The remainder is the coterminal angle. You'd have to use long division. So in other words, there's a way of saying this. 30 degrees is 750 degrees mod 360 degrees. So that's modular arithmetic. We don't really use that very much in calculus at all, but it's used in other places in math. So it's the remainder. That's how we write this. Look at B, where I say have alpha. Oh, okay, there's no part B. That wasn't part A. Let's do another example. Find an angle theta such that theta is again between 0 degrees and 360 degrees and coterminal to negative 135 degrees. So the solution is we add 360 degrees repeatedly until we get our answer. So what's going on here is that if I add 360 degrees, I'm going around the circle counterclockwise. So the thing is that I could either use a calculator, or I could do this in my head, or I can write this down the way I'm doing here. So it's 225 degrees, and that's our answer. Now this, if you're not using this method, if you're using, say, a remainder method, and you add a large number that's negative, then you divide by 360, and you look at the remainder. So you could divide by 360 and get the remainder, but the remainder still will be negative. But it'll be a negative number that's between 0 and negative 360. So you'll get something like this, and then you add 360 degrees. It's a little bit tricky, and I don't even think it's worth the trouble. It's mostly playing around with numbers. So essentially what you do is you either add 360 or subtract 360 repeatedly until you get a number between 0 and 360 degrees.